And welcome back to the very last lesson, 24.2, Confidence Intervals and Margins of Error. Explain 1. Finding a confidence interval for a population proportion. So in here, confidence interval for population proportion. A %C, which is denoted as the confidence interval for proportion P of successes in a population, is given by this very long formula that we'll be using in our equation. So here, just like we've been doing on our mound, where our mean is somewhere in the middle, here we subtract our standard deviation. Here we add our standard deviation. And you see they do the same thing. They subtract and they add. All right. Where that P with a little hat on it is the sample proportion, where N is the sample size, and that Z-score depends on the degree of confidence. Okay, so let's go ahead and go over some of the things that we're going to use. It says there are only two possible outcomes. So the one outcome and then the other outcome. And this is not new to us. We actually saw this in the last lesson. We still have to multiply our sample size times our P and N times 1 take away P, and that has to be at least 10. So that's another thing we did in the last section. We had to verify that it was at least 10 to see that it was a normal distribution. So we're going to kind of use the same thing. And then the sample size must be at least 10 times the size of the sample. So the size of the population, the size of the population must be 10 times the sample so that the sample can be random. And the sample must be random. Okay. So now that we have this information, we're going to utilize it for our first part A and part B of Explain 1. All right, for Explain 1, it says finding a confidence interval for population proportions. So depending on our degree of confidence, we're going to use the following values for Z. So just keep that in mind. And it says in a random sample of 100 4-year-old children in the United States, 76 were able to write their name. That's cool. Find the specified confidence interval for the proportion P of 4-year-olds in the United States who can write their name. Okay. So let's identify some information. Let's highlight some stuff up. So we kind of highlighted some things. So our N value is going to be those 100 from the random sample. So that's our random sample. Our P value is going to be whatever 76 out of 100 is. Because out of 100, there were 76 who were able to write their name. So go ahead and work that out as a decimal. Should have gotten 0.76 when you divided the top numerator divided by the denominator. And since we're getting a 95% interval, we're going to utilize that number 1.96 as our Z value. All right, now we're going to go ahead and calculate some stuff out. So let's go ahead and plug in some numbers. For our P value, we got 0.76 and 1.96 for our Z value. For our P value again, 0.76 and P value again 0.76. Let me make sure that point is actually visible. And then our N value, or sample size, was about 100. So let's go ahead and work this out. In fact, we can actually put this in our Desmos calculator. I want to show you how to do that, just so that way you know how to calculate maybe the next one. All right, just to review your Desmos calculator to make sure that you know how to use it. All I did, by the way, is just I went to Desmos.com. I have so many options. I can graph stuff, and I have a 4-function calculator. I'm going to use the scientific one though. And this is what pops up. So let me enter in this equation that we have here. 0.76 minus 1.96. Ooh, and it calculates it in real time. That's cool. All right, I'm going to go ahead and square root. Ooh, and since it's a fraction, I'm going to put it the fraction key, that's A over B. I'm going to put the top portion, 0.76, parentheses, 1, take away 0.76, close the parentheses. I'm going to move down to the bottom and write 100. Ooh, it did calculate that for me. How awesome is that? So I'm going to write that here on our document. Okay, 0.6762. I'm not going to write the whole thing, but just, maybe the 4 digits that come after the decimal, just so it could be as accurate as possible. Again, let's plug in some values. So our p-value is the same. In fact, sorry, the screen spazzed out. So that would be about 1.96. So essentially I'm just copying this down. The only difference is here I was subtracting, here I'm adding. That's really the only difference. So if that's the case, let me go back to my Desmos calculator and see if I can just change that minus to a plus. And voila, I don't have to retype in everything. I can actually just write down our number that we got, 0.8437. And let's actually round that, since we are going to use our percentages. That would be about 0.68, since the 6 is higher, so round up. And 0.84, since 3 is lower, we'll keep it there. And they do want us to write this as a percent. Remember, we showed you how to do that. You just multiply by 100 for each, and we would get about 68% and 84%. All right, let's go on to part B. So for part B, again, there's our intervals, so keep those in mind. And let's highlight some important information. So again, our random sample is going to be 100 4-year-old children, and 76 were able to write their name. Find the specified interval for a 99% interval. So instead of 95, we're going to use 99%. So feel like the only thing that's really going to change for us is that z-value. Our sample size again was about 100. That was our random sample size. Our p-value is 76 divided by 100, which as a decimal is 0.76. Our z-value in this case will be 2.576. So let's go ahead and plug some numbers in their place. So our p-value is 0.76. Well, that's our p-value. Our z-value is about 2.576. Our p-value again is 0.76 and 0.76 again. And our n value in this case is still 100. So not much has changed. In fact, I can actually use my Desmos calculator here, since a lot of those values are already plugged in. The only thing I'm going to change is my z-value to 2.576. And as you can see here for part B, I also forgot to change that to a minus, so let me go ahead and do that here first. Alright, that's more like it. Alright, so it's kind of a nifty tool to use for our Desmos calculator, just so you know. Alright, so with this calculation here, as we could see on the screen, that's going to be about 0.6499, and we can actually round that to about 0.65 since 9 is bigger. And let's go ahead and continue on down to find our other range. So 0.76, adding instead of subtracting 2.57, that's a very interesting 7, 6. Let's go ahead and bring everything else down. And hey, since our Desmos calculator has all those values, we're going to change that subtracting to adding. And that's going to be about 0.8700, which is really just 0.87. And we can change those to percent, so we can multiply that by 100 and that by 100, and that should be about 65% and 87%. Just as it says here, stop and do the problems in your packet and make sure you're following these steps.